Happy Wednesday, folks. We have had our MB4000 horizontal since late March of 2022, so a little over 6 months. It's been an absolute game changer having a horizontal with automation. It's not an exaggeration to say we would not have been able to make it through this year and do what we did without it. And for reasons I'd love to explain and elaborate on, we do absolutely love it. It's an absolute beast of a machine. But we were first-time buyers of a horizontal, and there's a ton of things we now know that we didn't know when we were going through this process. So I wanted to take some time today in this video to try to share and help out folks that are still using vertical machines or thinking about automation or thinking about horizontals, and just help educate. For those of you that are maybe new to the channel, I started out in New York City in 2007 with a TAIG benchtop CNC machine, and it's now been 15 years, but we've grown to have a number of different vertical and now horizontal machining centers, and it's been fun to kind of share that story. But the real goal is helping everyone be both better machinists in terms of making parts, but also making the right decisions and informed decisions when it comes to spending the kind of money it takes to buy these machines. So we have a couple other videos talking about the more specifics of what we bought, so we'll put those in the video description. But I will start off by saying one of the things that we did do correct was we bought this machine with two key options. Number one is having the 218 tool ATC matrix. This is, I don't know if it's necessarily mandatory, but this machine, I think the smallest ATC, which is the normal default, is only 60 tools. There's a 100 tool option, but the problem is that for this particular machine, it's a very unusual option, and I think it requires a bit of a different ordering process to get that sent in from Japan, and thus is uncommon. This is that 218 tool matrix. I know it's a little bit difficult to see in right there, but that really plays a role in the key of what this machine is in terms of it being able to have a number of different part families, being able to run unattended, being able to have sister tools, and it's just really a key part to it. Even more important though is right here. I will say, I've been kind of joking, if anybody out there is thinking about buying a horizontal with just the traditional horizontal format, where you have one tombstone that's in the machine and you have the second tombstone that's outside of the machine, sure. Are they very productive compared to even a vertical machining center? Absolutely. But it's a totally different class of machine compared to what we have here, which is the 6 pallet pull APC. The way we now literally think of having this machine is, you can kind of argue it's 24 machines in one, because if I walk up to, this DT1 or GT2, sorry, or this VF2YT, both are great machines. We love them. We use the heck out of them, but it's one machine with one table, one setup. In this case, we have a nice sized tool changer. I think this YT has 50 tools, which is great and a bit unusual, but it's still only one table. On this horizontal, we have 6 tombstones. Most of the tombstones have 4 sides. That's 24 different setups that can live in this machine at any point in time. So if you've run vertical machining centers, you should get that right now. You hit a button and you have one of 24 setups that just pops right up. Vices, fixtures, setups, op 1, op 2s, like it's just incredible. That being said, one of the first kind of lessons I wanted to mention that we learned is how difficult it was to understand tooling this up. The cost and the math behind it, that's not really a surprise, and that's not the point of this video. Anybody can do basic math. Tombstones are not inexpensive. The vices and so forth are not inexpensive. And even the tool holders themselves, 218 tools. A pull stud alone for this machine is between $40 and $70. So you got 5 figures potentially of just pull studs alone to tool it up. The tombstones and the vices, etc., that adds up. But the thing that we found was really difficult was what size tombstones to buy. We started off with, I'll walk up here. We started off with a square tombstone, actually that one right there that we've got covered in Saunders fixture place. That worked out great. It gives us a lot of flexibility. Obviously that's our own product line, but it's our product line that we use to make our product line. To be honest, that's not a great setup. It's still kind of a temporary one, but that speaks to how we've brought this machine online. So that was our first one of 3. That was our second one. I like this style here because it gives us 2 big faces, and we actually are able to still make use of this smaller side, which I would guess some folks don't, but being able to have that 6-inch face, a custom fixture on it, works out great. And the third one right down here is this hex-sided one that has been an absolute excellent fixture for holding round bar parts to make our reversible inserts. But I very much found it was a kind of a chicken or the egg thing, where I didn't know what to order until I had some experience making parts. But once you had experience making parts on this machine, that means you've already bought a tombstone. So hopefully sharing some of those example setups can give you an idea. But like anything in fixturing, do your homework. For us, we hit this time crunch because we needed to quickly make a decision to buy this machine because we found one in inventory. And that meant I didn't necessarily have the luxury of spending days or weeks to pull up Fusion to load up different sample tombstones where you can download the tombstones, fixturing vices, part families, and start thinking about the layout. But I did that, and you should do that. On the flip side, always encourage when it comes to fixturing, don't build this big complicated fixture that you think is going to work in your head and it looks like it's going to work out great in CAD. Build a single one, build a one-off, and that's what we're doing on that test one I mentioned right in through there. Is we're just sort of seeing, hey, how does that work out? And if it does work out, and then we're going to kind of tweak things to optimize and maximize the machine itself. It's a great segue to the second lesson, one of the biggest ones out there, which is all horizontals seem to have very different y-axis travel. And I didn't realize this until kind of right at the very end. And the travel differs both in the y travel distance, but also in where that y travel exists. The Okuma is pretty good. It's the y travel goes down to, actually it's gonna be easier to show on a tombstone itself. I'll pull one out here while we're talking. Which one do I want to play with here? So if I hit 3, enter out, it's actually pretty cool. It will pull that out. And it's actually funny, we do a pretty good job at keeping our machines clean. It is like almost impossible to keep this cleaner than it is. You can wipe it down every day, but it's just so productive. Even if we were to take the time to clean this out, in a couple hours it looks like this. So I've kind of learned to accept that that's just the way it is. Okay, it's done moving. I can hit this button and start that door open. That lets me open the door. And we now have this operator load station, which lets me pull the handle. And then even though this whole assembly weighs probably 700-800 pounds, it's fairly easy to rotate by hand. So on our Okuma, the y-axis starts about the bottom of this chamfer right here, and it goes up 22 inches, which is going to be right about here. The buddy John over at Area 419, who I believe has some Mori NHX 5000s, their y-axis starts a bit higher up, I believe, which means when he went to do some of his fixture and tombstone machining, he didn't have the ability to reach down this low to actually drill or face or clean up. So it's just something to kind of be aware of. I've also seen, Matsuras, Okumas, Haas, some of the other folks out there, Makino would be another brand that comes to mind, have different Y dimension travel. And y-axis is really where it's at. This machine has about 22 inches in X and Y. So I've got the tape centered right there. It would go to about my thumb, left to right. So you basically have plenty of X, but the Y is what kills you. So I've got the tape measure there, and that Y travel sure enough ends right where my thumb is. So that's really the limiting part in terms of just how productive you can get this machine. And it's why we've spent a fair amount of time trying to think about part layout. As an example, our Saunders Machine Works top jaws happen on the fixture right here. And you can see we're using our own dual stations to get 8 parts on there. Actually got a couple different ideas to change that so we can get a little bit more on there, but nevertheless, it can be fairly tight on that front. We also keep a cheat sheet right here showing, I'm gonna block my serial number, but showing all the information that we need to know that's critical to this particular machine. I think we covered that in one of our other shop update videos as a template that we have now on all of our machine tools. Okay, next big lesson learned, and this is probably one of the biggest ones that's it's obvious, but it doesn't really hit you until you start running one of these machines, is, I'm going to be honest, it is a huge pain in the butt to load parts. Having run vertical machining centers for 14 and a half years, moving to a vertical surface stinks. it absolutely stinks. Yes, you get the benefit of chip evacuation, and this machine overall, I love it. But when we go to say move this part from op 1 to op 2, or to load these tombstones up or pallets up right here, the fact that the parts tend to move or fall or gravity works against you, I'm not looking for sympathy, I'm just telling you, it stinks. We've thought about some different fixtures that have little preload pins to help hold the part in place, or you get good at holding the wrench in the part and turning it. Everyone knows that's like, right, that whole, like, you lean into it, you hold the part, you use the wrench to get it in there. So we're working around it, but you know, we regularly drop tools or parts, unfortunately, because it stinks. So something to keep in mind that we didn't really expect. And look, this machine is incredibly productive, but it would probably take most of a working day to swap every single surface of every single tombstone out. That's not a drawback so much as it is just the reality of there's a lot of things that you can do and set up. And of course that depends on how complicated your setups are and so forth. Better fixtures could make that a little bit easier. The real next step, if the volume would allow for it, would be moving to something like a hydraulic fixturing. I know Vectech is a company that makes a lot of that stuff, but you're talking about going into the thousands or if not tens of thousands of dollars for true automatic clamping like that. So this isn't a problem or a bottleneck for us, but it has caused us to really think about how we balance the load of the machine, because like right now we're not behind, but we have an imbalance where we need more of these parts. And I only have these on one tombstone right now. So we're basically running it, and then we might run a quick job on another tombstone while this comes out, and we spend 20 minutes to reload, in this case 4 op 1s and 4 op 2s. What we're moving to, and that's actually a great example, is I think the guys were setting it up late last week. Yeah, bingo, right here is we're adding a second tombstone that'll have sort of an identical version of that setup. In this case, we'll have 6 op 1s, and then we'll do 6 op 2s on the other face. So that's another great example of thinking about not only the parts that you want to make on it, but what's the balance or the load. If you put all the parts on one tombstone, it might be easier to pattern in CAM and save some time on tool changes because you're able to run them all at once. But it also means that 4-hour run might be happening and you don't have the ability to get the next one running so that you can really crank one specific part family. The other lesson that we learned, this one totally caught me by surprise, is we have a real issue with our scraps that come out of this machine. We do probably about half steel and half aluminum, or certainly a large percentage of each. And we have a Mayfran Concept 2000. It's a really high-end conveyor that sorts and it has 2 different conveyor outlets. This one actually pretty cool. This one scrapes the bottom of the tank to get the fines out. This one's your main conveyor. And right now we put them into these Gaylord bins that we have to sawzall the top out because we have them on a pallet to load them, and that's on top of a U-line style or U-line spill containment because a little bit of coolant does leak out, and we put that on wheels so that we can wheel it out. This is all kind of a learning and a work in progress. The learning in the lesson is that unfortunately that's mixed material. Now I hear you, you could say big deal, this machine is so productive and it's making us parts, and ultimately making parts is how we make money. Full stop, I get it. But it's not hard for this machine to make what could be $1,000 to $2,000 a month in scrap for us. And that's of course depends on how much material you're removing and the value of the scrap and all that stuff. But it's not nothing. I mean, if you think about it, $2,000 a month times 12 months a year, you can do basic math. And for us, our scrap price goes from being, I think, pretty normal to basically 1 penny per pound, like nothing when it's mixed. So it is potentially costing us $20,000 plus a year to not be able to sort the scrap. There's a couple of ways we've talked about on the BOM of trying to solve that, but it's not a simple, easy solution that I can implement right now. Another lesson that, again, I knew, but it doesn't sink in until you actually live it. Tool management is a bear. And it's a bear because this machine often runs overnight. When I say, sorry, it always runs over outside the shop hours or lights out. But some of the product families we never run during the day because it's better to have those products being run at night. So we never hear the part being made. So that makes it really difficult to handle tool life management. And yes, there's the typical signs of tool break detection for things like drills. End mills will usually often streak, but it's just totally different than you know, we have a high feed mill and a face mill on that machine, and we all now know, and I'm sure if you guys are working in a shop, you know, when that tool starts to go, you hear it, and you know, even in a loud shop, you know, ooh, those inserts sound like they may need to get looked at. This machine, you don't get that benefit, and frankly, when it's running, it's just not on top of your mind. And yes, you can go around to the back of the tool matrix and you can restore the tool that it has pre-staged, and then you can pull up a tool that you want to look at, any kind. It's totally doable, but frankly, it's a pain in the butt. And to do that for a bunch of tools, you can do it, but I would say it would be an hour for us to probably check a lot of the common tools. So instead, what we try to do is check them while the parts are running, or run one every once in a while, and see what the insert looks like when it's, you know, when that tool is called up in the spindle. There's other things that we can do with tool life management in terms of spindle load for sure, but I'm just saying it's not super easy to do that. To set a load limit of a face mill isn't necessarily, well, it's just not that simple. Tool break detection is probably the best thing. Actually, I'll show you right now. We've got one of our engravers right up there, and it's probably one of the coolest things about this machine is inside of that is a little, I call it like the R2D2 Renishaw. So this is actually not the best tombstone to show it on because you're going to get a bit of a blocked view. But if I call up, actually if I call up this tool right now, you'll see it's tool 3, and it has a height of 3.1364, and in our Okuma, this may be different on yours if you're running an Okuma, we have an M code of M202, excuse me, which is the break detect. And we have preset a range, I think it's 10,000ths of an inch, that if it's shorter or longer than that, then the machine will stop. So M202, enter, cycle start, oops. It's going to pop up that little hut. Oh, I'm sorry, I can't do that because actually this is a great lesson too. We're in automation mode. I've got to move back into manual mode. That's kind of letting me use the machine myself from here. M202, enter, cycle start. I love this. It pops up a little housing, spindle comes down, tool comes in, and again, you can't see it right now, which is actually kind of horrifying, but we would have had an alarm had that tool failed. So this has been a really nice way for us in Fusion 360 to have manual NCs where after any tool we care about, you know, your drills, your taps, even your end mills that are roughing and have that chance or slotting of breaking, just call up an M202 after certain operations, and if the machine fails on that, then it'll stop. Now, I was just talking on the Business of Machining podcast how, as great as that is, this machine, so far as I know, doesn't have an elegant way of handling that. If a tool breaks, it just stops. And what that means is, let's say another tombstone could be run, it doesn't need that broken tool, it doesn't know that, and it doesn't move ahead. Not a big deal for us right now, but I do have a Wise webcam that I often will put facing the machine, and there's definitely been some nights where I'll look at 8 or 9 o'clock, I'll see it has a broken tool alarm, and I'll come in and I'll either fix that tool or I'll just skip that program and start running the next one. 3 last quick lessons here, or comments. For us, the 6 pallet pull APC, each of the tombstone pedestals are individually bolted to the floor. This really surprised me. I really thought that this would have been one giant weldment or assembly or casting that itself could be kind of moved around. And I don't particularly like that it's done this way, because it means that moving the machine would mean, you know, undoing what, there's 6 of these, probably 4 anchors per, so 24 concrete anchors. And again, each one of these could be moved independently. It would be very expensive, it's complicated, it requires templates to set up and alignment processes, versus what I kind of thought it would be, which is just one thing you bolt on to the side of the machine that frankly could have alignment pins that don't even need much alignment. But if you're looking at automation options for whatever machine tool brand, it's one of those questions that I would never have thought to have asked until I saw it show up, and I thought, wait a minute here, where's the APC? Because there were just 6 individual little pedestals that they mounted in accordingly. The other lesson that blew me away is this thing drinks coolant. There are probably days where we add 20 to 30 gallons every day, and we are in a climate controlled shop. We're not, you know, Southern California with no AC. So the fact that it uses that much blows me away. I think the coolant system is about 200 gallons. I don't think we have a ton lost to run off. I mean, for sure some. I just think it's one of those things where it's so productive. It's, you know, we're like amateurs at running this machine at this point, or maybe we're like one notch beyond amateurs, and it still is easy to have this machine run. Garrett gets in now at 6 in the morning. He'll get it started, and I'll usually finish it off or help get it loaded off, and it may run then till 8, 9, 10 o'clock at night. That's like a low stress scenario where to have this machine run 14, 18 hours a day. And so that's just totally different. I've read some articles about how vertical machining centers, it's hard to get above like 50% spindle time on a vertical. Of course, depends on the parts you're running and all that, but this just has so much more uptime. So it's probably not fair to say it you know, unnecessarily uses coolant. It just uses a lot more, period. It's actually a great comment too to tie back to the way we tend to run this throughout the day is Garrett will start it off and get products that we know are more important that we need to get made, like the Saunders Machine Works products. And then usually like from 10 to 2 or so is when I'll have some free time. And that's when I'll say, hey, can I take over the machine? And I'll do some R&D stuff, some one-offs, some new fixturing, some testing. Garrett, or one of the interns now, can be loading up the other tombstones, and then it'll go back into its production mode, automated pallet mode at 2 o'clock and run throughout the rest of the day. And finally, a little bit of a silly point, but it's really easy to have a tool get lost. And what I mean by that is, you know, we had a helicoil go bad. I wanted to set up a 1/8 inch end mill to interpolate out something so we could get that helicoil out. It's really easy to have that tool end up lost in the machine or in the ATC forever. Some of that's because I don't love how Fusion 360 handles tool management across multiple different CAM files or automation solutions like this. So what we've tried to do is we'll put in little, this is not a great solution, but it's a Band-Aid, is we'll put all of the tools that we want to know about in here. So like I know right now that 125 is a fan, or I'll pull up another one, 77, actually this is now T36, is actually not a great example because it's not very well. Here we go. Tool 113 is a 1024 form tap. But what we'll do is if we know it's intentionally going to be a temporary tool, is we'll do that on one of those tags, or even put it right up here so that we know after a week or two to say, oh, you know what, we should take that form tap out that we're never going to use again, because otherwise it takes up one of your ATC pots forever. Or even worse, you know, the holder plus the collet plus the pull stud could be $400 or $500 that just sits there unused for a year. And you want to have confidence that if you take that out, it's not a tool that one of the part families or programs that you're running actually needs, because that can really bite you. So again, the goal of this video is to share some of the frustrations and struggles and lessons that we've learned for those of you out there that may be thinking about taking the step up to a horizontal. But like I said, even despite some of those lessons, this machine has been absolutely incredible in terms of how productive it is and how fun it makes machining. Because again, think about that ability to have any fixture you want and any tool you want pulled up at any point in time and run it. And then when you don't want to run it anymore because you're busy, you can go back into production mode and it can just make other products. So as always, folks, I hope you learned something. Hope you enjoyed. Take care. See you soon.